welcome to True Projects. In this video, we are going to explain about the project that is Mental Health Safety and Depression Detection in Social Media Text Data, a classification approach based on deep learning model. So before getting into the execution, first let us understand what is this project about. Mental health. It's a key part of overall well-being affecting how we think, feel and handle daily life. Depression is one of the most common and serious mental disorders globally. People experiencing depression often feel sad or low for extended periods and lose interest in things they usually enjoy. It can also cause changes in sleep, appetite, energy levels, and also concentration, making everyday life challenging. In severe cases, depression can lead to feelings of worthlessness or even thoughts of self harm. Detecting depression early is very important because it allows timely support and treatment, which can prevent these negative effects on a person's health, happiness, and quality of life. Nowadays, social media becoming part of daily life. People often share their thoughts and feelings online. This creates a valuable opportunity to understand mental health because people posts can reflect their emotional state. However, social media posts are usually written in a casual and informal way with slang, abbreviations, and emojis. These forms of expression carry important emotional cues, but they are often difficult for traditional depression detection methods to understand. This makes it harder to accurately identify signs of depression. Because of this, there is clear need for smarter, more flexible approaches that can interpret the informal and constantly changing language on that is used on social media. So, the proposed system is built to detect signs of depression by analyzing what people write on social media and the emotions expressed in their posts. Social media languages is often caused that is often casual and filled with emotion, slang, or emojis. So, understanding it requires advanced techniques. So, to handle this, the system uses BERT, which is bidirectional encoder representation transformers, a deep learning model that understands the meaning of words in context. This helps the system to grab subtle patterns, subtle differences in how words are used in different models, that is, in different situations. The output from the BERT is then pre-processed, that is processed by BiLSTM model, which is another type of deep learning model that looks at sequences of words. And this allows the system to track changes in the tone or emotion across a post, which can reveal signs of depression that might not be obvious from individual words alone. To better understand the informal and expressive language people use on social media, so the system includes some extra modules, that is slang normalization, emoji handling, and emotion coding. So the slang normalization module, it converts casual or shortened words into their standard forms, while emoji handling module, it translates the emojis into text so that the emotional meaning is not lost. And the emotions coding module, it measures the overall emotional tone of the post, helping the system to detect subtle feelings or sadness, frustration, or hopelessness that may indicate depression. And all the information from the BERT by LSTM and these additional modules is combined and passed through fully connected layers, which are enhanced with techniques like ReLU activation, batch normalization, and dropout to ensure the model learns effectively without overfitting. Finally, the system uses sigmoid activation to classify posts as either depressed or non depressed. The model is trained using ADAM optimizer and binary cross entropy loss, and its performance is measured using accuracy, precision, recall, FN score, and AUC to measure the reliable predictions. Moving on, to further enhance this project, as an extension, we are incorporating several enhancements. So first, we have applied mode to handle class imbalance. Then comes advanced data balancing techniques. So the depression detection system is further improved with this advanced ensemble techniques, combining LSTM and GRU networks with the BERT and embedding with LSTM GRU. Additionally, a voting classifier has been implemented to contribute the strengths of multiple models, improving overall prediction accuracy and reliability. Then comes explainability model. So, explainable AI techniques like LIME and SHAP were added. These tools helps to explain why the model makes certain predictions, highlighting which features are most important. making the system more transparent and supporting better clinical decision making. And we have developed front end using Flask framework with the user authentication. This allows users to input the text and receive depression detection directly through the interface. And only registered users can log in the system and use it. And finally, topic modeling using latent dirichlet allocation has been applied to the dataset. This helps to uncover common themes and patterns in the social media posts, providing additional context that supports the analysis and understanding of mental health trends. So this is how we have implemented the project. Now moving on to the implementation. To implement this project here, we have followed the steps which are mentioned in the flow of work. So let's understand them. First, we have imported all the necessary Python libraries and tools that are imported to handle data processing, modeling, visualization, and deployment. Then comes data ingestion. So at this stage, the social media depression dataset is loaded into Pandas data frame, making it ready for analysis and processing. Then comes pre-processing. At this stage, the text is clean and normalized by converting it to lowercase and removing HTML tags, URLs, and unwanted characters. Punctuations is handled, text is tokenized, and labels are encoded to prepare the data for model training. Then comes embedding or the vectorization. At this stage, the text is converted into numerical representations using Keras tokenizer, TF-IDF, and BERT embeddings so the machine learning models can process it. Then comes data visualization. So at this stage, the data is explored visually to understand the sentiment distribution and identify common words through word clouds, helping to gain insights into the data set. Then comes data balancing. At this stage, techniques like smooth and random oversampling have been applied to handle imbalance, ensuring the model learns fairly from all type of data. Then comes feature extraction. So here at this stage, important features are extracted and the data set is split into training and testing sets to evaluate the model performance effectively. Then comes model building and training. At this stage, various models, including baseline model, BERT-based model, and ensemble models, are built and trained on the process data set to predict depression from social media texts. And we will be evaluating all of them using accuracy, precision, recall, and FN score and confusion matrix to measure the performance. And explainable tools that are LIME and SHAP are used to understand which features influence the predictions and make the model more transparent. Then the best performing model will be saved for the future use. Coming to the part of front end, a web application is built using Flask, allowing users to input the text and receive depression predictions. Topic modeling is integrated to extract key themes from the text, providing additional insights alongside the predictions. So this is how we have implemented. Now coming to algorithms used. These are the baseline algorithms that are used in this project, and deep learning models are GRU, LSTM, BiLSTM have been used. And coming to the proposed model here, we have used BERT with BiLSTM, that is with new module, slang, emoji, and emotional score, and BERT BiLSTM without new modules, that is without slang, emoji, and emotional score, and BERT LSTM with new modules, that is with the slang, emoji, emotional score, and without that these models. And coming to ensemble models, these are the other ensemble extension models that we have used in this project. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and hard disk of 25 GB. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. These are the source code files of this project. Let's understand each of them. In this folder, we have the data set that is used. So this is the depression data, that is mental health Twitter data. It's opening, just wait for a while. Here we have the Twitter data related to mental health. So this is the post ID. Here we have post created, post text, which it contains, user ID, followers, friends, favorites, states, retweets, and label. This is the target column that we will be predicting based on training these features. Now close this, get back. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap files, which are important for the project's appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have Jupyter Notebook file, which contain a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Just wait for a while. Now give the command cd, give the space, paste the copied path, click on enter. Here you can observe current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax issues, such as syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So just wait for a while. It's being loaded. So here you can see application has been hosted at this address. This is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I've copied it. I prefer Chrome, so I will paste it in that. Paste the link here and click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So to do the prediction, we need to get registered first. So click on register or explore the model. So let's click on register and create an account by entering all these details. I have already signed up, so I'll directly sign in. Click on sign in and give your username and the password. And now click on login. So we have logged in successfully and redirected to prediction page of the project. Here you can see a text box, right? In this text box, we are supposed to provide the input that will be pre-processed at the backend, and then it will be giving the prediction. And here you can see accuracy of the model and response time. Here we have samples analyzed out of 50 plus 1000 samples. So now let's open test cases for that. Open test cases. Open samples. Here we have multiple samples. And here you can see we have two labels, that is 1 and 0. One refers to one type of class, that is one type of prediction, and the other one is the other type. Let's check with the class 0. Apply filter to it. Click on OK. Select the tweet. Let's paste the text here. Now click on predict. So this given information, it will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us a prediction. So just wait for a while. It's being pre-processed and it's being analyzed. And here we got the prediction that is no depression. Here you can observe depression detection result is no depression. And here this is the clean text. And here we have topic analysis. So these are the main important keywords for the given word. And let's try with the another text. So let's copy the another text. Let's try with this one and paste it. Click on predict. And here you can see depression detection result, that is no depression. And this is the clean text after pre-processing, that is RT last night I got to tell both and how much I love their work, and I started Kristen Way, and we have some other text. And here we have topic analysis. The topic ID is 1, and here are the related keywords of the given word. Let's analyze the other text. So now let's apply filter to class 1. Click on OK. Let's check with this one. Now click on predict. And here we can see depression has been detected. And this is the pre-processed text. And here we have topic analysis. So detected topic ID is of 0. And here we have prediction as depression. So the text belongs to the depression type, where the person is depressed. Let's try with another text. Let's try with this one. Paste it and predict it. Here you can see it is depression. So the given text is predicted to be depression. And this is the clean text, and here we have topic analysis. Let's try with the last text. Let's try with this one. Get back, paste it, and predict it. Here you can see depression detection result, that is depression. Here we have text pre-processing, and here we have topic analysis. Now let's close this. Let's check with the graph. So click on about, and here we have sample outcome graph. Here on x-axis we have the classes that we are predicting, and on y-axis we have count of each class, and both are of same count. Close it. And here you can see distribution of text word length in words. Open it. Here on x-axis we have number of words, and on y-axis we have frequency. Close it. Here we have overall word cloud. This is the word cloud, which shows the most repeated words. And this is the confusion matrix. Here on x-axis we have predicted label, and on y-axis we have true label. Close it. And here we have accuracy comparison graph. This is the accuracy comparison graph. Here on x-axis we have all the models that we have trained, and on y-axis we have accuracy. Close this. Here we have precision score, recall score, and F1 score. So this is the F1 score comparison graph. Now here we have ROC. This is the ROC AUC. So ROC AUC refers to receiver operating characteristic under curve analysis, that is area curve analysis. And here we have RGR, that is ranking based evaluation metrics for the model performance. This is the RGA graph. And here we have XAI Sharp graph, which shows the model importance of each feature, that is each word. Close it. Now click on log out. So this project shows how social media posts can be used to understand people's mental health. By analyzing the words, emotions, and patterns in online posts, the system can help identify signs of depression early, supporting timely care and also better mental well-being for everyone. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.